Hello everyone, it's me Tabo and welcome to another devlog session, and today I'm going to be sharing some of the challenges that I've faced and some victories as well, so stay tuned. Now as you can see in front of me, I've got a list of tasks that I want to complete, so I will be taking you through each step, going through each one and showing how I managed to solve it. Okay, so the first task that we'll tackle is showing you how I fixed the raycast direction. Now over here I've got the code snippet. And what I used to use before is this get forward vector. Okay, so what this does, it actually uses the collider, which is the player, and not the camera that is parented to the collider. So it's using that collider's forward direction, meaning that when I'm looking around through with the camera, even when I'm rotating, it's still casting the ray forward, and it does not take the rotations into consideration. So any objects that are below the ray, for instance, any object that is on the floor, when I rotate to look at the object, it does not detect any intersections because the ray is not really hitting in its direction, it's still hitting forward. So that's what that did. I will illustrate what that means. So I'm just gonna walk through the stage and show you how that actually works. You see right now, I'm moving through the stage. I've got this green dot, which was the tooltip. So I'm actually showing you an example with the tooltip already in place, but I will explain that later. So in this tooltip, it's just showing you the name of the object that is being hit by the ray. Okay, just to show that there is an intersection. So right now it says dome room 03. And then now it's the test interactable, that would be the cube that is here in front of me. So you see at this moment, it's just casting in the forward direction. So any object that is ahead, it gets hit by the ray. Now for instance, you've got these objects over here. See, there is nothing happening. It still says dome 3. Go to the sphere and it's not detecting anything. What is being detected here is the dome room over here. So it's not taking the camera rotation into consideration, and that is not affecting the direction of our ray. So we want to change that. So as I said before, the code was using this over here, the get forward vector. And this is what the get forward vector is doing. So what I did is I just used this part. So I do not use any of this. I do not normalize the player direction. I just use that part, and this is what actually works. So I will demonstrate how it looks now. Okay, so now we'll go back here and then I will just get rid of this get forward vector. Okay, so let's see how it works now. Okay, so here we are. Test interactable, so that is normal, that is expected. But you see now, for instance, the main platform, as I'm looking down, the main platform is being highlighted. The main platform is the floor. So when I move up, so now it's so you can see the difference now. Now I'm gonna go to these objects. Ignore the frame rate. You see? Now I'm looking down, so it's detecting us. This is John Cube, and that is John Sphere. You see? So now it is taking the rotation of the camera into consideration. Basically, I'm just using that as the dictator of the raycast. Okay, so that managed to work. Okay, so next up I'm going to show you how I created a tooltip. Now the idea came from a project that I worked on earlier, and this is how it was intended to work. As you can see here, I've got this environment, and when I hover above this object, it is highlighted, and then there's a tooltip which shows what this object is or its qualities, whatever the case may be. So this works in this case because the mouse is free, the mouse is not really being used to navigate the 3D space. But in my case, this is not the case. Well, here I'm using the mouse to navigate the 3D space, so it means that the mouse coordinates will not be accurate. But anyway, I just used that just so that I could be able to, first of all, accurately detect intersections. So it served that purpose, but that's where the initial idea came from. What I plan on doing next is to maybe use CSS 3D. So that is still yet to be done. So in this instance, what this intended tooltip did is just to also confirm the center of my screen, because this is how this div is positioned. It's not actually centered, but the left upper corner of the div is the center. So this is where the ray is casting from. So at the moment, this is what I've got. It helped to confirm that everything is working fine in terms of ray casting, and it also confirms how this will work, because the plan is to use a sprite that will be centered, and then it will kind of dilate, just like your pupil. It will dilate whenever there is an intersection. So that will be cool. So you'll have this animation where it scales up and down according to the objects that it's interacting with. So this is the tooltip over here. This is just some simple CSS for that, and the main style is over here. Okay, so that's it for the tooltip. Okay, so next up, we will have a look at how I separated static from dynamic. Now the intention here was due to a misunderstanding, because when I first loaded my scene, which was all loaded as one, I realized that the objects were not responding to raycasting. So then I created two objects in Threejs to see if that would make any difference. And then I realized that these objects, which were created purely in Threejs, were reacting or were interacting with the ray that was being casted. So I thought that it was an org tree that made that so I decided that I was going to separate them. But even after separating them, I realized that it didn't make any difference. So what I did is that I went to blend, and then I created two different collections. I separated the collections. The main collection that you see over here, this is where the static objects are. And the second one here, interactables, this is where your dynamic objects are. So assuming that these would be the ones that I would interact with. So even after that, that did not make any difference. And so I realized that in Threejs, there's one thing that I did not take into consideration, and that is the intersect objects method. It takes your array, which would be your scene. Recursive is a boolean. So recursive mainly means that it will check the descendants of the object. Otherwise, when it's set to false, then it does not check. So what is happening is that because GLTF is exported as a scene, so it calculates everything as one. So each and every object that was part of the GLTF is kind of seen as one object. So therefore, you don't get any intersections because it is not considered a mesh, right? So it needs to then go into the descendants, which would be then the actual objects. But then when you set it to true, each and every object that it intersects, it checks to see if there are any children, which then slows down the rendering, which is why earlier I mentioned that you should ignore the frame rate. So this is what's happening here. By default, it is set to true. So if I set this to false, okay, so this is what happens after setting it to false. See, the tooltip is not appearing, because none of them are detecting, because it does not recognize them as meshes. All it just sees is basically an object which is a scene, but it is not of mesh type, so there is nothing happening. But if I go to the sphere, or these ones, you see, now that is working. Same as that, John Cube and John Sphere work perfectly. So this is the dilemma that I also have now, because if you notice, then the frame rate is it's not too bad. I've got 71, so that is not too bad, but without it being set to true, then I cannot detect anything else. And I do not have any desires of exporting any of these separately, because when you export them as FBX, then the size is not correct. Well, from my experience. So this is what I did. So another thing that I also wanted to, what separating them into different types does is that when I have that in the name in the code, then I can also choose to say which object should activate the tooltip. So this is how I did it, just as Okay, so I'm just gonna do this quickly because I thought I had done it. Now I've turned recursive to true, and I have I altered the code so that it will detect objects that are only considered interactable. Okay, so I'm just gonna go to one of you see now as I walk in here, because these objects are interactable, so it basically searches the name and then looks for the word interactable, and any object that does have interactable in its name is then activating the tooltip. Yeah, that's it for this part. Okay, the next bit is managing collisions and octree. Now here there isn't much that I have done. I'm just basically sharing all of this to make you understand the process that I have to go through, because now I realize that the recursion is the problem. Then I don't have to separate the dynamic object from the octree graph node. They can all go through it. All I have to do is just use the trick that I did with then searching the name and looking for objects which have interactable. Then I know that these are the objects that are supposed to activate the tooltip. The other interactables, they could be static. Yeah, they are static, but it's just that you can interact with them. So that's the difference. So I then went to have a look at the code, because my code is based on the octree example from the Threejs scene and at how they manage the collisions. So one thing that I noticed in this code is that they have, well, the original octree code, they have a sphere and a capsule. So these are the only two shapes that they have. So for instance, if I had a cube that I wanted to manage or that I wanted to make dynamic, then I would have to somehow figure out how all of this is done and then alter this code so that it can do the same thing for me, but using a cube. So this is what I have to figure out. Okay, I must say, this is all new to me. So I'm just showing you that this is also something that I kind of have to learn as I go, to really look at the code and try to figure out what is being done here, to understand what's happening first of all, and then figure out if I can somehow alter it and make it do what I want. Okay, and that's why some of the things really take long to do. So that's basically my process. Okay, so at the moment there are no solid objects that I've thought of that I will animate, but I will think of things that, you know, to make the environment lively. So yeah, I think I'm just gonna cut it short and leave it there. So I will keep you updated, and so until the next one, I will say love and peace. I'm out.